Okay, so this is, in theory, supposed to be a demo video for the material properties lesson, and I had to re-enable screen recording on my my laptop here. All right, so I'm going to quickly do my table design. Okay, so I set some dimensions on that to be like 1 inch by 2 inch by 4 inches. That looks like 7 inches. So, so I'm going to make the length of my table 3.5 inches. We'll make this 1.5 inches. So there's the dimensions of that. And then I'm going to extrude this. This is the eating surface of my table. So I'll extrude that 1/2 inch. That sounds good. Now I'm supposed to use a fillet somewhere on here. So I'm going to fillet, fillet there. Fillet the edges around the top there. So I'm going to select the edges around the top. And right now I have a fillet of like no inches. I'm going to try 1/10 of an inch. I think I kind of like that. That looks pretty good. But now that I see it, I think I'd like to fillet the bottom as well. I just think that is a nice look. So I'm going to select fillet again. I could have done all of this at once, but I am kind of winging this. So those of you that like to entertain yourself with counting how many times I say this would be a good video to do it because I am totally winging it. So what did I say? 0.1 inches. Okay, I like that. Now I need to put some legs on this table. So I'm going to turn it. I'm also doing this without the benefit of a mouse. And I know you guys like to design all the time without a mouse, but not me. So I am, what am I going to do? I'm going to make the legs on here circular, I think. Nope. Okay. And let me see. I'm going to do a circular leg. That looks pretty good. I think I'm happy with that. And now I'm going to do a rectangular pattern. I'm going to pattern the circle itself in this direction and this direction. But I only want one. Oh, that's not what I want to click. There we go. One in each direction. So let's see what that looks like. And then, oh, wait a minute. Two. Sorry. There we go. All right. So I'm going to drag that over. It's kind of lousy that I can't see the edge of it there, but, and then drag that down. Negative 0.5 inches. Let's do negative 0.75. Yeah, I think I can live with that. Okay. All right. Those aren't centered exactly the way I would, but remember in class, I'm giving you guys a 25-minute time limit on doing this. So I'm going to seed whether or not I can make this perfect. Now, the other requirement is to do a tapered extrusion. So I'm going to extrude all 4 of these legs, and that is not what I wanted to do. Crud. It says I've got 5 selected, which is not really what I wanted. So I think I made this 1/2 inch, and I think I'm capped at 1 inch on that. So the most I can extrude it is 1/2 inch. Well, that is clearly not what I wanted to do. So let's try that again. 1, 2, 3, and 4. we're going to extrude this 1/2 inch. And I was supposed to do it tapered, so let's put a taper angle on there of 30 degrees. Well, that's not what I imagined, but I kind of like it. Well, not at that, but about 10. I kind of like it. I'm going to do that. That's not what I had intended to do, but but I like it. Okay, so there's my table. So it has the required dimensions. It includes the fillet, and took me about 5.5 minutes to design that. So I think 20 to 25 minutes is certainly enough for you guys. So now I'm going to expand the bodies here. Now I've got a couple different bodies in this design, and you might have more depending on how creative you get with it. But I have body 1. Oh, you know what? It's all as one body. Well, no, that's fine. Okay. I'm thinking about whether I want to split the body bit. I guess not. Okay, so one of the things that we can do in Fusion is we can assign properties to it. So I'm going to right click over here on bodies and then go up here to physical material. And that's going to pop up a dialog box, I think. There we go. In the right hand side. And the first thing that I'm supposed to assign it is brass. So we do have to go through this and try to find the brass. Oh, wait a minute. There, right there. Okay. Well, maybe. Good grief. I don't know how y'all do this with the mouse all the time. All right, metal, and let's go find brass in this list. We have all kinds of different aluminum. Brass. Okay, so the way I assign brass is I'm going to click it and then drag it onto the table, and then we'll close the dialog box. Maybe. I can't see the bottom of it. There we go. Okay, and you'll notice that Fusion changes the visual appearance of the object as well. So what Fusion is going to do is say, okay, if you were to design this table and you were to actually make it out of brass, it's going to let us know the physical properties. So I'm going to right click on the body again, and just make sure when you're doing this that you always pick the same thing. And I'm going to go to properties, which is right there. And it's going to give me all kinds of properties of this table. So it tells me the surface area of the table. Notice it's in square inches. It tells me the density in ounce mass per cubic inch, which is a strange unit. It gives me the mass in ounce mass, the volume in cubic inches, the material is brass, and so forth. And so what you're going to do with yours, and it also gives like some physics properties like the moment of inertia, the center of mass, and so forth. So you are going to fill that in on your sheet. Okay, so you just pretty much click properties. Now you have to change the properties. So we are going to go into physical material. And when my dialog box comes up, I'm going to click on, I right click on brass, and I'm going to say unassign, and that unassigns it. So the next thing we're looking at is glass. So I'm going to open the glass menu and click and drag glass. So that's pretty nice there. And then come over, right click on body and do properties again. You'll notice that the surface area is the same, but the density and the mass are dramatically different. Okay, and the volume should stay the same as well because we haven't really changed the shape or like what the object is, but we have changed what it's made out of. And so you're going to do that. Now, the last part of this, you're going to do a little bit of research on what dollhouse furniture can or should be made out of, and you're going to repeat the process a third time. So I think I said in the video lesson about 10 or 15 minutes to do that, to do a little bit of research. You have to reassign it, but you can tell that the assigning and reassigning the materials takes almost no time at all. And then a quick explanation of what you why you made the choice that you made. All right, so the second part of this activity, we have to design a prism, and I'm trying to remember off the top of my head what I said about this prism. I think it had to be 2 inches by 3 inches by 4 inches or something. I think. I don't really remember, and it honestly doesn't matter for this. So there's my 3 inches by 4 inches, and then we'll extrude that up 2 inches. And then we need to put a hole in it somewhere. So I'll go ahead and put my hole in it. And this needs to be dimensioned at a 1 inch diameter. Finish the sketch. And we're going to cut that hole all the way through. Okay. Now in the same file, well, this is not the greatest. I am going to what did I just do? Okay, I don't know what I opened there. Draw a cylinder, and this time I want the cylinder to be 1.1 inches in diameter, and then we'll extrude that up. Great, I have that oriented just how I wanted it. Not exactly. So now we'll open this up. We're going to turn each body into a component. So that's going to allow us to move these around, maybe. Yeah, there we go. To move these guys around, and then ground the prism. Capture position, that's fine. Okay, now I need to move this. Like, this is not oriented the way that I would like. Let's see if I can grab the right circle there. Well, that is not what I wanted to do. It is slowing me down a little bit to try to do this without a mouse. I brought a mouse home with me, but I'm not sitting where I can use it real well. So I'm just going to move this closer to the position that I want it to be in. And we're going to assemble a slider joint. And we'll select the outside of that, and then the inside there. And that should be good to go. Let's slide that down a little bit. Maybe. Okay, so I should be able to drag that through. Now we know that this is not supposed to fit, and if you look real closely at that on the screen, it really does not look quite right. So what we're going to do now is run what's called an interference test. So on yours, you're going to place your cylinder here. I'm actually going to edit this a little bit. I'm going to go back in my timeline. If you look down at the lower left, yeah, that's the one. I'm going to right click. I'm going to edit the sketch because you're supposed to do it to 1.1. But what I don't want is anybody watching this video to just use my data values from the video. So I'm going to say 1.05 because you've got to do 1.1 and you also have to do something between 1.1 and like 1.2, I think. So I'm going to go a little bit smaller so that my number will not work for your activity, so nobody can watch this video and just copy my numbers. So now I'm going to go to the inspect and interference. So inspect menu and then interference. We are going to capture the positions, and then we have to select what we are going to choose. So I want to make sure that I select these two components. Yes, I want to include the coincident faces, so I check that little box right there, and then we're going to check compute. And what this tells me is that there is a volume of interference of 0.161 cubic inches on that. And now if you watch the video, what you can see here is that it actually shows me where that interference is. So it's totally okay up here and down here, but right where that cylinder is intersecting the box is where we're getting that interference. And then we'll click OK. Now what you need to do is do what I did. You're going to go back into that timeline and change the diameter. Now this time I'm going to change it to something like stupid big, okay? Because again, I don't want people using my data, from this video. I just want to model how it's done so you guys know how to do it on your own. But I'm going to pick like 1 point. You guys have to pick something between 1.1 and 1.2. So I'm going to pick 1.3. I'm going to pick something that's too big, and we'll finish the sketch. Okay, and so I just want to show you what this does look like. We go to inspect, interference. We are going to capture the position. That's just because I moved it. We want the cylinder. We want the prism. We're going to include coincident faces and compute. And notice that the volume of interference is much bigger because I made the cylinder bigger. So they are overlapping more. And now this is what I wanted you to see, because before it just kind of looked like it was highlighted because the volume of interference wasn't very big. But now you can see that it's pretty substantial. Let's see if we can turn it. Yeah, so this is the amount of volume that is exceeding the volume of the diameter of the hole there. So that's what I want you to do. So you're going to use some slightly different dimensions than I did, and you're going to fill out the chart, but the process should be the same. So hopefully if you miss any of the in-class lesson, you fall behind, or you're absent that day, this video will clarify for you what it is that you need to do. I did the entire activity in less than 20 minutes, so it shouldn't take you a lot longer than that to be able to complete it. So let me know if you have questions, as always, and I'll do my best to help you out.